Okay, so get this. Something absolutely huge has just wandered into our solar system, and it came from another star. This thing, this interstellar visitor, is already raising some really profound and fascinating questions. So let's dive in and explore what we know so far.
So let's just start with a number, a really big one, 700,000 kilometers. I mean, what in our solar system could possibly be that big? Well, that's the kicker. This isn't the object itself. This is the size of its coma. You know, that huge envelope of gas, dust, and plasma that's surrounding its core. And just to put that into perspective for you, its coma is half the diameter of our own sun. That means that the atmosphere of this visitor is, right now, the single largest continuous structure in our entire solar system. Let that sink in for a second. So, what is this thing? Well, its official name is 3I/Atlas, and it's only the third confirmed interstellar object we have ever detected. And as you're about to see, it is completely, utterly unlike anything we have ever encountered before. It's not just the size that's blowing our minds, it's the speed. This thing is booking it. Right now, it's moving at 58 kilometers per second. That's already faster than Mercury, which is our fastest planet. And here's the crazy part. It's still speeding up. It's on track to hit nearly 68 kilometers per second when it slingshots around the sun.
So, we've got this massive, super fast visitor on our hands. But what's it made of? What's under the hood? Well, let's take a look at how powerful telescopes like the James Webb are starting to decode this interstellar messenger. The chemical signature we're getting back is just weird. It's incredibly rich in carbon, especially carbon dioxide, but it has very little water ice. That's pretty much the exact opposite of most comets we're familiar with from our own solar system. This is a huge clue. A composition like this might be telling us something incredible about the chemistry of the star system it came from, a system that could be very, very different from ours. Now, you might remember our first interstellar visitor, Oumuamua, from back in 2017. That thing was a total mystery, but it was also tiny and it was gone in a flash. This comparison really shows you why 3I/Atlas is such a game changer. Oumuamua, no visible coma. Atlas, 1/2 the size of the sun. Oumuamua's nucleus was tiny. The one on Atlas is estimated to be around 50 kilometers across. This is a whole different ballgame. It's not even in the same league. So what is powering this enormous active coma? I mean, what's making it glow and expand like that? The answer is incredible, and it actually takes us into some pretty exotic physics. We need to talk about what's acting like a plasma engine at its core. All right, first, a super quick refresh on plasma. It's often called the fourth state of matter. Basically, you take a gas, you pump it full of energy until the electrons get ripped away from the atoms. And what you're left with is this electrically charged soup that interacts really strongly with electromagnetic fields. Fun fact, about 99% of the visible universe is actually plasma. Simple enough, right? Well, here's the twist. 3I/Atlas isn't just surrounded by any old plasma. It has what's known as a complex dusty plasma. And that word complex, that's where things get really wild. You see, a complex dusty plasma isn't just a passive cloud. It's an active, self-organizing engine. The plasma itself actually creates its own dust. It can arrange itself into these intricate, almost crystal-like structures. And get this, in lab experiments with carbon-rich plasmas, just like the one around Atlas, they've been observed creating nanoparticles, things like nanodiamonds and graphite. It's like a cosmic factory wrapped around a giant rock. Okay, so let's recap. We've got this giant object wrapped in a self-organizing plasma factory, and it's hurtling through our cosmic neighborhood. What happens when something like that enters our solar system? Well, let's look at the ripples it's already creating. Now, this is a really, really important detail. Unlike the other visitors that kind of dove in at a steep angle and left quickly, 3I/Atlas is traveling nearly flat, right along the ecliptic plane. That's the same disk all the planets orbit the sun on. And what that means is it's going to spend a long, long time interacting with the solar wind and the electromagnetic circuits that connect our entire solar system. It's basically cruising down the main highway. And we've already seen this interaction play out in real time. Just back on August 21st, a massive solar storm erupted from the sun. Now, the main blast missed us here on Earth, but a huge wave of high-energy protons slammed directly into 3I/Atlas. It essentially got zapped with a massive jolt of energy, which likely supercharged its plasma coma, causing it to expand and become even more electromagnetically active. All of this is happening right now.
as this visitor hurtles toward the inner solar system. So, the big question on everyone's mind is what happens next? The timeline ahead is absolutely packed with moments to watch. So in early October 2025, it passes Mars. Then on October 21st, we get this fascinating alignment. It lines up on the far side of the sun from us, along with several other planets. Just a week later, it hits perihelion, its closest, hottest, most energetic point. And even after all that, it swings back out for a close pass with the giant Jupiter in March of 2026. And this really just highlights how new all of this is for scientists. As analyst Stephen Burns puts it, we can't apply much of our current knowledge base to understanding what 3I/Atlas is. It's its own classification of object. We are well and truly in uncharted territory here. We're off the map. Which leads us to the final, most mind-bending question this object raises. We've seen that its plasma can form these ordered crystal-like structures. It's an active, self-organizing system. So, what is it carrying? Is this just a really unique comet? Or, as some in the source material speculate, could an object capable of this kind of complex organization be a kind of messenger, maybe carrying information or even a form of consciousness from a distant star system? It's a mystery that's going to keep scientists glued to their telescopes for years to come.
Welcome to the debate. Today we're digging into, well, frankly, an astonishing object currently passing through our solar system. 3I Atlas. It's an interstellar visitor moving incredibly fast, up to 68 kilometers per second at its closest approach.
And it's big, really big. The nucleus alone is estimated somewhere around, 50 kilometers across?
Exactly. But the real puzzle, the thing that's forcing us to rethink things, is its coma. It's primarily carbon dioxide, and it stretches out 700,000 kilometers. That's practically half the diameter of the sun.
Which is unprecedented, no question there.
Right. So the core question we're tackling, based on the source material, is this. Is 3I Atlas, with its immense scale and highly ionized state, basically telling us our standard cometary models are broken? Or is it just a really, really extreme version of processes we basically understand?
A sort of outlier, but within the known physics.
Well, I'm arguing that the sheer dominance of its complex, dusty plasma state means we have to expect unique electromagnetic effects on a massive scale. Our standard gravity and sublimation models, I think they're just fundamentally insufficient here.
And I'll be taking the view that while, it's extreme, what we're seeing with Atlas is fundamentally an energetic response. It's driven by sublimation, photoionization, interacting with a huge carbon-rich body. Enhanced processes, yes, but explainable within our current physical framework. It's an extreme case perhaps, but not necessarily demanding entirely new physics.
Okay, so let me lay out why I think the standard model just falls apart here. We're not just talking about, water vapor and some dust, like a typical comet. This is a complex, dusty plasma. Now, when gas gets hit by solar radiation, solar particles, it ionizes. The molecules become electrically charged. And the second that happens, the physics, it fundamentally shifts. Its behavior becomes dominated by the electromagnetic force. And that force, well, the measurements are clear. It's something like 10 to the power of 30 times stronger than gravity. It's almost incomparable.
That's the standard physics number, yeah.
Right. So imagine this object has a charged coma 700,000 kilometers wide. Given that sheer volume, that high level of ionization, it seems unavoidable that electromagnetic dynamics, not just gravity or simple gas pressure from sublimation, are going to dictate how it interacts with the solar system, how it moves. Gravity barely gets a look in at that level.
Okay, I see the emphasis on the force difference, like you. But I think the key word you used earlier was ionized. Ionization is a consequence. It's not the starting point, right? Our observations like from JWST, from SphereX, they confirm this thing is massive, yes, but specifically it has a very high CO2 to water ratio. It's carbon-rich.
Agreed.
And that composition is highly volatile, especially now as it gets closer to the sun and especially during solar maximum, when the sun's output is way up. the ionization you're focusing on, I see that as the natural, frankly expected, result of intense UV radiation, X-rays, solar wind particles, all hitting this enormous cloud of released gas.
But the scale.
The scale comes from the sublimation. The solar heating is driving off enormous amounts of these volatiles. That's the engine, in my view. Ionization is the state that gas enters because of that solar interaction. And, we shouldn't mistake the size for fragility. Some calculations suggest that sublimating just a tiny layer, maybe a millimeter thick, around that huge 50-kilometer nucleus over a couple of years, that's actually enough to produce this giant coma. So the underlying mechanism, it still looks like energetic volatile release, just scaled way, way up.
Let's talk about that release, though, because you're framing it as sort of a passive cloud, like steam coming off boiling water, right? Sublimation happens, gas floats away. But the presence of plasma, especially dusty plasma, that makes it an active system, maybe even a generative one. It's less like steam, more like, well, maybe like a kind of natural 3D printer on a cosmic scale.
Generative. How so?
Well, look at laboratory experiments. When you create CO2 plasma, particularly dusty plasma, it doesn't just sit there. It inherently starts to generate new complex structures. You see things like crystalline formations, plasmoids, even exotic materials like highly conductive graphite, maybe even nanodiamonds forming within the plasma itself. This isn't just gas spreading out. It's plasma potentially organizing, building new things under electromagnetic influence.
Okay, lab experiments are one thing.
But we know 3I Hamus just got hit hard, right? There was that confirmed CME impact, relativistic protons slamming into it back in August. That would have massively surged the ionization, boosted the plasma component. So if this generative process is happening, driven by EM forces, that's what could be dictating the coma's evolution and its enormous size, potentially pushing it even larger, maybe past the sun's diameter. It's an active plasma process, not just passive gas.
That's an interesting point about internal plasma dynamics. But I'm sorry, I'm just not quite buying that EM generation is the defining reason for the coma shear size. Let me explain why. We have to follow the mass, right? The spectral data, the flux maps we have, they show this incredibly clear spike in carbon dioxide and a corresponding lack of water ice.
Right, the composition is unusual.
Ionization happens, absolutely, but it's often a temporary state before the ions and electrons recombine. So while you might have an active plasma layer, maybe doing interesting things internally, its actual substance, its mass, its composition, that's still built on the foundation of gas and dust physically released by solar heating and particle impacts. The fundamental energy source driving the vastness of what we see, I still think that's the sun's energy hitting those volatiles on a scale we just haven't encountered before.
I'm still not convinced by that framing, mainly because of its trajectory and its orientation. These factors seem to predict systemic electromagnetic effects that go way beyond just simple photoionization of released gas. Think about it. Atlas is moving retrograde, opposite the planet. But it's only tilted about 5 degrees from the ecliptic plane, the main plane of the solar system.
Yeah, very low inclination.
Which means it's spending a long time embedded right in the heart of the inner solar system's electrical structure. It's cutting through the heliospheric current sheet, interacting directly with the main flow of the solar wind for months on end.
Okay.
Now compare that to Oumuamua, our first interstellar visitor. It shot through on a very steep angle, high inclination, very brief interaction time. And yet, even with that fleeting passage, some studies noted correlations, maybe coincidental, maybe not, with things like X-class solar flares and even a big earthquake near its perihelion. Now, if a small, fast-moving, high-inclination object showed even potential correlations, how can we dismiss the influence of 3I Atlas? It's vastly larger, it demonstrably has this huge active plasma coma, and is positioned perfectly for a sustained electromagnetic conversation with the inner solar system's circuitry, especially around October 2025, when it's near Mars and aligns with Earth and the Sun.
That is. Well, that's a compelling point about the alignment, the low inclination trajectory. And yes, it cutting inside Mars' orbit is definitely significant. However, we have to be super careful about correlation versus causation, right?
Of course.
Remember, the Oumuamua flyby also happened during a period of notable solar activity. Attributing specific flares or, a random magnitude 8.2 earthquake somewhere on Earth to this tiny interstellar object, that feels like it risks confirmation bias. We need stronger evidence for a direct link. And focusing so heavily on the plasma potentially causing unusual dynamics, are we maybe overstating the influence of what is still ultimately a very low-density mixture of gas and dust, even if it's huge in extent?
But it's charged.
It's charged, yes, but compare its influence to the sheer, overwhelming power of the sun itself, especially during solar maximum. The sun's magnetic field, its particle output, that dominates the inner solar system environment. Isn't the influence of Atlas, however interesting its plasma is, likely just a secondary perturbation on the background conditions set by the sun?
But the scale of that charged sphere is the critical factor, I think. You have an electromagnetically active object, half the sun's diameter, plugged right into the solar system's main electrical pathways. And we've seen it react strongly to solar events like that proton storm. This isn't subtle. It looks like active, massive-scale EM physics in action.
So when I put all the pieces together, the high CO2, the evidence for plasma generating complex materials like graphite, maybe nanodiamonds, the sheer scale, the near ecliptic path, its interstellar origin, it really forces me to consider that this might be a fundamentally new class of object, the first of its kind we've seen. And maybe we need to stop calling it a comet, even an extreme one, because that label might be blinding us. It could be locking us into outdated models and preventing us from seeing the unique plasma physics really driving its behavior. This thing forms somewhere else, under totally different conditions. Shouldn't we treat it as, I don't know, an interstellar messenger requiring new thinking, not just stretching old definitions?
Okay, intellectual caution is really crucial here, though. Yes, the data is unique, but what does it point to most directly? An extremely carbon-rich object, highly volatile, very large, and it's reacting, energetically, to our solar system's environment. The things we observe, the ionization, the coma structure, that CO2 spike, these are still measurable results of physical processes we do understand, like sublimation, photoionization, particle collisions, just happening on an absolutely enormous scale.
But is understanding the components enough if the system behaves in a totally novel way?
Well, my position is we should probably classify it, for now, as an extreme variant. Maybe an extreme carbon-rich interstellar comet or something similar. Until we get specific unambiguous data showing that electromagnetic forces are not just present or important, but are the actual primary driver, that they're actively overriding the known effects of solar heating and sublimation on this scale, we should stick with refining existing models. We have to resist, I think, the temptation to declare a whole new physics regime just because we're seeing something incredibly intense, especially if that intensity still kind of aligns, even if it's straining the edges, with what we know.
Fair enough on caution, but I think we need to remain acutely aware as this thing heads inwards that its huge, complex, dusty plasma envelope means we're watching an object heavily influenced, maybe even governed, by electromagnetic forces. And that, I believe, could easily lead to dynamics across the solar system, effects on the sun, maybe even interactions with planetary magnospheres that go far beyond what our standard gravity and gas models would ever predict. This plasma structure feels almost alive, electromagnetically speaking, and that suggests we could be in for some surprises.
And I would reiterate that the observations we have so far, including those detailed JWST spectral maps, still provide really strong evidence that massive sublimation of carbon-rich ices is the foundational mechanism. It's the bedrock upon which the plasma effects are built. So yes, let's watch carefully, let's gather more data, but let's proceed with the understanding that the high ionization, the plasma activity, it's likely a direct, if spectacular, consequence of intense solar energy hitting this unique body during solar maximum, a body that's journeyed from vastly different conditions out there in interstellar space.
Well, it seems the mystery of 3I Atlas really does highlight this ongoing tension in astrophysics, doesn't it? Between our familiar gravity-dominated models and the increasingly recognized importance of electromagnetism across the cosmos.
Absolutely. And there's clearly so much more to learn as this incredible object makes its closest approach around October. The data we get in the coming months will be absolutely critical.
Indeed. It will be fascinating to see which perspective, the extreme but known, or the fundamentally new, gains more traction as we observe it up close.